Alright guys, wanted to see if you guys had any questions, specifically about the homework assignment. I wanted today to be a work day, so we could answer and ask any questions we wanted to, and see what we could do to get better.
So in standard position, can we just draw out like just the graph and just mark it out, or do we have to have the circle?
You don't actually have to have the circle itself, but you must have the arrow indicating which direction it's going in and how many times.
Okay.
Yes. So in standard position, I usually draw with a circle because that's how I've been trained to do it. But as long as you have the terminal and the initial sides in the correct position, with the arrow indicating the correct direction and the number of rotations, it is the correct answer. Okay? Fantastic first question. Thanks, man. Other questions? Like we can go through specific ones, or look at some of the formulas again if we need to. The goal is to be comfortable and ready to turn this in tomorrow. So, questions? 15? 1-5? Yeah, sure. So 15 states I want to draw an angle in standard position that is at negative pi over 10. Is that right? 15, yeah, negative pi over 10. Marker into the pocket, of course it is. So 15. I want to draw an angle in standard position that is negative pi over 10. Now, I'm going to draw it the way I normally do, with the circle, with the pieces. Again, it's up to you whether you want to do that entire amount. If you just want to draw the initial and terminal sides, as long as the initial and terminal are in the correct spot, and the arrow is indicating the correct direction, you're good. Okay? Let's do this. I'm going to draw it like I normally do. Here's my plus sign, with my unit circle. Such a beautiful unit circle. I know, I've been practicing. Okay, here we go. So, I want this to be at negative pi over 10. I have two options. I can attempt to graph this directly using negative pi over 10 and estimating its location. I could also convert it to degrees and graph the degree version and then just mark it as negative pi over 10. Because again, both are going to be the same solution because the degree and the radian shouldn't change its location. So I'm going to graph it directly the first time, but I will also showcase kind of how to do it the other way. It's a little bit more work, but for some people it's easier work, so they'd rather do that. It's the difference between climbing over a wall versus going around it. It's, if you're able to climb, like you're going to climb right over, be fine and do it quickly. If you're not, you're going to be like, I'm going to walk around. Okay, so let's do this. This one, remember for my initial angles, I have 0 degrees, and that's also 0 radians. I would have pi over 2, pi, 3 pi over 2. I also have, and of course, 2 pi. Since I'm going in the negatives, I know I probably want to go in the other direction. So this will be 0, and this would be negative pi over 2. This would be negative pi, and this would be negative 3 pi over 2, and also negative 2 pi. So I want to go specifically to where negative pi over 10 is. Now, negative pi over 10, if I'm not comfortable with the fractions, this can be a little bit tougher. But remember, the larger the fraction, the smaller the value. Again, the larger the fraction's denominator specifically, smaller the value. Large in the bottom, small for the big thing. So I can come in here and go ahead and break this apart into 3 pieces. So here I break it in half. If this is negative pi over 2, that would make this negative pi over 4. I can break it into my thirds. One there. Squeak, squeak. This would be negative pi over 6 and negative pi over 3. Remember, the larger the number is in the bottom, the smaller my value is for the angle itself. So remember, I know it's going to start here from my initial side on the axis. So this is negative pi over 10. Negative pi over 10 is larger than negative pi over 6 in terms of the denominator. So it's actually going to end up somewhere in here. Because you can just see that with these 3 values, right? Negative pi over 2 is here, negative pi over 3, negative pi over 4, negative pi over 6. So negative pi over 10 should be somewhere in here. And again, I'm not looking for perfection. If I wanted perfection, I would instead grab a protractor. My goal is to be able to eyeball it and make sure it's always in standard position. Now, it is not finished yet. There's one final piece to get this entirely correct. The arrow. There must be an arrow to indicate which direction I'm going in to get to this angle. Remember, I could go counterclockwise, which is positive. Or I could go clockwise, which is negative. Since this is a negative pi over 10, I'm going to go counterclockwise. I put my arrow right there. My arrow should start on the initial and end at the terminal. So it starts right here on the initial and goes to the terminal. So this here in red, I'm going to erase all the extra information. This angle here in red is my solution. Now, alternatively, I could have also done this by converting it into degrees first and gotten a similar solution. Now, when I do that, this angle as a degree is negative 18 degrees. Again, I can use my formula using 180 over pi to convert it, and I would get negative 18, which makes sense because remember, negative pi over 6 would be negative 30. This would be negative 45. This would be negative 60. This would be negative 90. And so negative 18 would be between 0 and negative 30. So again, it still ends up in the same spot. But again, I should make sure that if I start with negative pi over 10, my solution should contain negative pi over 10 as well. So note the pieces I need. I gotta make sure I have the angle in the correct location with the correct initial side and the correct terminal side with the arrow indicating the direction. Because remember, this terminal side without that arrow could represent many different angles because I could have various different rotations and various different directions. So I must make sure to put it in the right spot. 15 is done. Thank you, everybody. That was a good question. Other questions in the homework 7? The question. Number 4? Of course. I would love to do number 4. Number 4 states, how does radian measure of an angle compare to degree measure? Include an explanation of 1 radian in your paragraph. If you Google this phrase, you'll find that people have written papers on this stuff. I wouldn't recommend it. It's a lot to read. It's a lot to write. Don't do that. Instead, simplify it down. Whenever you have a compare and contrast question, like if you're taking an ACT, one of the most common things they ask for the written portion is to do a deciding portion and say, which of these is the right answer? One of the best ways to write for it is to compare and contrast the two. And say, here's the good things about this one, here's the good things about the other one. Here are the bad things about this one, here are the bad things about the other one. So I would compare these two and say, okay, what does a degree do? How do we talk about it? What does a radian do? How do we talk about it? That'd be one easy way to fill this out. A little bit different way would be to talk about them in terms of the picture. Draw a picture of a degree or a radian angle and compare the two and what their value is. For example, I could come up here. Draw my standard position angles like normal. I could sit here and say, well, at 0, they're the same. But my first angle that we talk about on the unit circle is at 30 degrees, or pi over 6.
I need Raphael Carbajal and Brooks Stankowski to the office, please. Raphael Carbajal and Brooks Stankowski to the office, please.
So, 30 degrees is equivalent to pi over 6. That'd be a comparison between the two. I could even convert this into a decimal and say pi over 6 is something like 0.481, I do believe. Question mark? I'd probably want to type that in and get an answer. So I could be like, hey, 30 on one scale is roughly 0.5 on the other scale. Like there's a clear comparison there in terms of their values. I could list out the formulas and be like, hey, to go from a degree to a radian, I multiply by pi over 180. To go from a radian to a degree, I multiply by 180 over pi. Once again, the problem's asking us, how does the radian measurement angle compare to the degree measures? That's a very broad question. I could give a picture version, I could give a formula version, I could write out a couple of sentences. They're probably expecting the written one, so I'll put that up here as well. I'll show you an example of that one too. So a written version of this. a degree is randomly assigned 0 to 360. A radian is made using a radius from 0 to 2 pi. That'd be my answer. What have I done? I've declared what a degree is. Well, it's random, but it goes from 0 to 360. A radian is defined as being made using the radius, which we talked about one day in class, and it goes from 0 to 2 pi. So I've given a comparison. So they both start at 0, they both end at a number. In this case, one of them is 360, one of them is 2 pi. One's more random, the other's more built using a number, radian. Now, include the explanation of what a single radian in your paragraph. So 1 radian, we actually talked about this in class one day, but if you didn't write notes on it, you probably forgot. 1 radian is equal to the length of 1 radius. We actually showcased a little picture, a little graphic that made the little radius wrap around the circle to showcase what a radian is. There's my 2 components. I've declared what a radian is. I've declared what a degree is. I've showcased what 1 radian specifically is. It's a length of a single radius.
This is interesting.
Interesting is a very strong word, London. I don't know if that's quite accurate.
Well,
Just making sure. Okay. There's a lot of directions you can go on these first 4 questions. Some are like, will all have pretty similar answers. Some you could have totally different answers, and it'll still be fine. The goal is you should understand at a fundamental level that there is a difference between a degree and radian, how to talk about the two, and where a radian comes from. Thank you for asking about number 4. It's a great question to talk about. Any other questions from homework assignments? We've done number 15. We've done number 4. 16?
Yeah.
Sure. So 16 asks about 415 degrees in standard position. Okay, I'm going to work through this one just a little bit faster than last time. But again, same process. I start off. Circle. Grid. Beautiful, I know. My marker is dying. I'm sorry, Alexia.
Very close. Very close.
I'm going to say I won because, I couldn't see otherwise. Okay, so this is in degrees, so I'm going to make my unit circle in degrees. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Remember, I can keep going, because remember, the degrees keep increasing or keep decreasing depending on which direction I'm going in. So this is 0, but it's also 360. This is 90, it's also 450 degrees. This is 180, it is also 540 degrees. I'm sorry, we are doing number 16. I could continue this and just keep getting bigger and bigger numbers, but I'm already well past where I'm supposed to stop. The problem states for number 16, I want to do it at 415 degrees. So again, I'm going to come in here. I'm going to find my 3 pieces. On the first round through, this is at 30 degrees, 45 degrees, and 60 degrees. On my second time through, this is not 0, it's 360. So 30 past that would put this at 390. 15 more would put this at 405. 15 more would put this at 420. I'm sorry. 420. And obviously 450 is too far. So if I want a graph where it is, it's supposed to be at 415 degrees. First, I have to put my initial side down. Where is it going to end? Well, it's going to end between 405 and 420. So I go in between these two. I can see that it's closer to 420. So I'm going to put it right about there. Clearly in between the two values, but clearly closer to 420. And again, I could also do the visual techniques where I break it down into thirds to get even closer in value, or break it in half to get even closer in value. Now, this red line could be at, 50 or close to 50, or it could be at 415 like we want it to be, or it could be in the negatives. That's why the arrow is so important, to verify which answer is correct. So we start at 0. So right here we are starting at 0. We proceed around the circle. 90, 180, 270, 360, up to 390, 405, and then what we hope is 415.
I just confused on how you call it.
Okay. So what I like to do is exactly what you heard. You heard me count my way up to it. I know I'm supposed to stop at 415. 0, 90, 180, 270, 360, 390, 405, 415. Because I know that I'd have to get there eventually, so I just literally start my marker closer to the center, and I just start making a little spiral on my way out. And again, if you haven't been hypnotized by your homework assignment because of these spirals, I'm sorry. Make sure to say encouraging things to yourself. Okay. Now we go to 16. Good question, everybody. Thank you. Other homework problems. So do number 4, 15, and 16. Great questions so far.
Would you recommend turning it into a 3 to graph it? I mean,
If you are not good at the fractions, you should get to the right answer. What the hell was that? They cause more drama than they're worth. Boom, roasted. Sorry, not true. All right.
I forgot your video.
Good, that's the way I want it. Can't stand that fakeness. All right. So, what I'd recommend, get to the solution. If you need to go to degrees to do that, then do it and do not feel bad about it. Do not ever let somebody put you down for something like that. I can do it in radians because I've practiced it for years, and I am fully comfortable doing it in radians. If you are not, and you're like, don't want to, then just do it in degrees. It works. Trust me.
Are you recording right now?
No, I am not.
Okay.
So to get to the 3,
He's recording
180 over pi.
Yeah, I was thinking
Yeah.
recording itself so you post it.
So if I was going to do, for example, the last problem we had, right?
Tonight too.
Number 15? If I was going to do that problem and convert it into degrees instead, I would take the negative pi over 10. I have to multiply this by that fraction, which to convert from radians to degrees would be 180 over pi. So now I use some fraction rules. So the pi's are going to cancel, leaving me with, on top, we multiply top times top, so negative 180 over 10 times nothing is 10. I can then cancel to reduce and get negative 18 degrees. So negative pi over 10 is equivalent to negative 18 degrees. And I find that if you are not strong in your fractions, it is just easier to use the degree because it is nicer. It's not a nasty number. You can also convert them all to decimals. Like negative pi over 10 is negative 0.314. And so if I convert all of them to decimals, then it's a little easier to see where it's supposed to go because I can, again, just get close to it without going over. Okay, other questions?
On the standard angle standard,
Sure.
there's the vertex on the initial side and the terminal. Is that on the other side of the
So in this
the
picture,
other line?
this right here
Is the initial.
is the initial.
And
This
the vertex.
is the vertex.
And so the other line.
And
would
this
be-
red line right here is,
The
this is
terminal?
it's the terminal.
Okay.
But remember, we have to put it in context. That's what the arrow's for.
Okay.
Because again, looking at this picture, this could be at, 50 or 55 degrees. So I use the arrow to indicate that no, it's actually at 415. because I've arrowed it to be clearly past 55.
On like 19,
19?
it goes around like several times. How do you
Want to do it? 19? If it goes around 7 times.
Yeah, this is terrible. It goes around at least 3 times, and then on the 4th time, it's going around 7.
Well, I guess you're going to have to be real good at drawing that arrow. Yeah? Okay. Here we go. So you said this is number 19?
Yeah.
All right. So this one's in radians. So I'm actually going to do everything in radians. 0, pi over 2, pi, 3 pi over 2. Okay. Now, there's a little cheat you can use. Rather than drawing out the entire unit circle and counting up the entire unit circle, I'm going to focus on the one it talks about, which is all the over 3s. Okay? This is 22 pi over 3. So I'm going to take the unit circle and I'm only going to pull in the ones that are over 3s and use those to count my way up to it. So for example, right here is pi over 3. Right here is 2 pi over 3. 3 pi over 3 is, of course, pi. 4 pi over 3 is right here. 5 pi over 3 is right there. 6 pi over 3, well, that's just 2 pi. So right here, this would have to be 7 pi over 3. This would have to be 8 pi over 3. This would be 9 pi over 3. Also called 3 pi. This would be 10 pi over 3. This would be 11 pi over 3. This would be 12 pi over 3. I'm not going to lie to you. Normally, I wouldn't write all these out. I'd mentally count them out. I'd be like, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I make this one 13, 14, 15, 16, 17, 18, oh, I'm getting close, 19, 20, 21, and now 22 pi over 3. Oh my gosh. Okay, so that is 1 full turn, 2 full turns, 3 full turns, stopping here. Ready? Initial side first is going to start right here. It is going to end at 22 pi over 3. It's going to end right there. How do I showcase that in my picture? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Looks like a beautiful spider web. And I can clearly see 1 turn, 2 turns, 3 turns, stops there. It takes a little bit of practice. Not as much as you think, but still a little bit of practice to get it right. And if you mess up, you can try to erase it, but I'd probably just, because I know where it's going to start and end now, I'd probably just do a quick redraw and not have to do all those numbers again. It's like 1, 2, 3, 4. So yes, this is how I would do it. If I had to do more, I'd have to keep going. Now I've drawn these so wide that eventually I run out of space. So you probably have to restart and make them all nice and thinner. I mean, again, you can clearly see this starts at 0, wraps once around, twice around, 3rd time, stops at 22 pi over 3.
That looks like a spider web.
Thank you.
Well, it was not like.
I took it as one.
Okay.
I'll be honest with you. Whenever I have to do art, if I have to do a spider web, I do a unit circle. And then I spin my paper.
Oh, geez,
Most
really?
math person I've ever known.
Why do you have to draw a spider web?
I like doing art.
Oh.
I think having something that is not something you are good at.
Then I can take the shortcut.
Because for me, it is relaxing. I don't have to feel pressured to be good at it.
Yeah, well, I've given up on cloud vision too.
Then you would not use art the way that I do.
There
But I have friends that the only reason they play basketball is because it's relaxing for them. The only reason they hang out with certain friends is because it's relaxing for them. Everybody needs a little something in their life. You say what you want. I say what I want still. I've already sworn twice. No, I didn't. Any other questions?
Well, on number, okay, I'm just making sure that I did this right.
Sure.
On number 2, it says, oh no, I wasn't even looking at number 2, I was looking at number 3.
No 3?
It's like what I remember. Yeah.
Number 3?
So number 3, when it says statement of positive or negative angle signifies you're positive, you're just going to draw your arrow. Is that what you're asking me?
I would say my answer would be a positive angle indicates you are turning counterclockwise.
Okay.
A negative angle indicates you are turning clockwise. That's how the unit circle works, right?
Yeah. I just wanted to make sure that's what you're
Of course.
asking for.
I'll happily answer. There are also ones down below that involve using these formulas. We haven't asked about any of these yet. Did you have any troubles with them? You want to work through a couple of them?
I would not have any.
Okay. We'll also have some time for questions tomorrow.
Oh. Are we going to have the quiz tomorrow?
Nope. Homework is due, though, at the end of class.
I messed up my round on this, so I'm sorry for stopping.
It's okay.
It's pretty bad.
If I graded for art, I'd fail every time.
So on 41, like I know how to do it, but like how do you want us to write these answers?
Sure. I personally encourage everybody on this homework assignment not to use a calculator at all.
Wow. So pi over 3 times 5.02. I don't want to do it right.
On 41? That's...
You just want me to write 5.02 pi.
How'd you get 5.0? Oh, 41, yes. Sorry, yes. I would write 5.02 pi over 3. Yeah, you better believe it.
That's it.
Yeah. So on 41, in case you haven't started yet, it involves using that first formula we have, talking about arc length. I discourage heavily the need for calculators in this class, which means that I want solutions that, in my opinion, are the original solutions, perfect and precise every single time. So for this problem, my solution would look like, first of all, my formula, my arc length is equal to theta times the radius. In this problem, for number 41, we already said that theta was going to be pi over 3. The radius, it says, is 5.02 miles. So my solution would be 5.02 pi over 3 miles. Now I believe the instructions state to round 3 decimal places. You can. I honestly prefer this solution. That's just testing to make sure you have a calculator that works, and that you know how to use it. And it's not actually what I need to know. I need to know that you know how to use the formula correctly. This is a perfectly acceptable solution for me. Now the actual solution, if you don't mind, I'll pull up my calculator. Actual solution, 5.02 times pi over 3 would be 5.27 miles. For these problems, 40 and on, make sure you have a unit with it. These are realistic problems. They are word problems. They should have a unit. If they do not have a unit, fixing. Yes, I accept both solutions. Many of your tests in this class, I will discourage you from having a calculator for specifically because I want you to use unit circle. Which means that for this problem, you'd have to leave it here. Because I would not expect you to take 3.02 times 3.14 and then divide it by 3. That's crazy. Other questions? We got about 8 minutes left.
So you want us to not use our calculator on this and leave it at that?
I would prefer it. I would.
On number 43, we have to convert like 50 degrees into radians.
Yes, you do. So on 43, 44, and 45, you'll notice they're all in degrees. Those formulas are designed to work with radians only. Sure. You want to do 43? Okay. Let's do 43 then. So the same formula is going to be used. I need to take theta, which is the angle, times the radius. So I already know the radius is 10 centimeters, so I can fill that in. But for the angle, I have 50 degrees. That is not acceptable. What I'm going to do, I'm going to convert. I'm going to use my formula. My formula is pi over 180. This would become 50 pi over 180. I could then cancel out a 0 on the top and bottom, leaving me with 5 pi over 18. And this would be the lowest possible answer I could have for theta. Now I can plug theta into my formula. So 5 pi over 18 times 10 centimeters. Remember, if you have a fraction times a number, just turn the number into a fraction and multiply top times top and bottom times bottom. This would become 50 pi over 18 centimeters. I would reduce, yes. So this would become 25 pi over 9 centimeters. Or, if you decided to use your calculator for this, you would get an answer as a decimal of, if you don't mind, 25 pi over 9. It says it is 8.73 centimeters. Make sure to round it correctly.
So we have to turn it into the radian?
You have to have a radian in order to use the formulas. You cannot use the degree. You have to have a radian. That is the advantage of starting and working always in radians, is the formulas are nicer. Because if you start in degrees, you have to then convert it to a radian, and then you can use the formulas. Now, that is not to say that there are not versions of the formulas that you could learn that are in degrees, but the formulas are like twice as big because they have to have the conversions in the formula itself, which makes it nastier. Remember, 40 and onwards, everything has to be in radians to use the formulas. And every answer needs to have
And that's only for
even
theta, correct?
correct. Obviously, if it's a distance isn't an angle, so we don't need to have it in radians. Other small tricks, if you look at 45, there's actually a small little trick in there hidden from geometry. 45 states, find the length of the arc with a circle of diameter 12. The formula doesn't have diameter in it. It has radius. So there has to be a conversion made on 45 specifically, because the formula does not require the diameter, it requires the radius itself. So yes, the conversion is, if you have the diameter, cut it in half and you will find the radius. So if the diameter is 12, the radius would have to be 6. But again, you have to see that that's a problem before you can know to do it. You have to be reading the problem and paying attention to it and be like, oh, it didn't say radius is the diameter, I better do that quick change. Oh, now it's an easy problem, just plug in 6. You've got to see it in order to use it.
So radius is always out of the diameter?
Always. Always.
I write that too.
Is that a bad formula to have? We'll have some time tomorrow for questions as well. We're about out of time. Any last minute ones before we go?
Any other roles we need to know? Should know for this?
No, I think that should be good. Should be a good list. We'll have some time tomorrow to work on them as well. These will be due at the end of class. Don't expect be able to finish the entire assignment tomorrow. I get as much as you can done and then come in with questions rather than hoping to do everything. All right? I'll stop the video and we'll see you guys tomorrow.